Okay, let's proceed, students. Now you are asked to find the solution for this one using undetermined coefficient method. So let's see how we can apply that one. So the solution for this goes like this. First, we have to determine the homogeneous differential equation, and next we will determine the particular solution. Then after, the sum of the two is going to be the final solution for the given differential equation. So the homogeneous differential equation is going to be y second prime minus 3y prime plus 2y is equal to 0. So as usual, we need to determine the characteristic equation for this one. So the characteristic equation is going to be m squared minus 3m plus 2 equals 0. So now this is a quadratic equation, so we need to determine the solution for this by using factorization or quadratic formula, and this can be obtained as follow. Think of two numbers where their sum can be minus 3 and the product positive 2. Clearly the numbers are minus 2 and minus 1, so this can be factored as m minus 2 times m minus 1 equals 0. So from this, the value of m that make this 0 are 2 and 1. Thus m is 2 or m is 1, as you see. So from this, a homogeneous solution can be the linear combination of e is a power of 2x and e is a power of x. So yh is going to be the homogeneous solution, and it is c1 is a power of 2x plus c2 is a power of x. So clearly the homogeneous solution is this. Now we need to determine the particular solution. Students, in the case of this, the particular solution mainly depends on the expression given here. Okay, the function given here. So the function given here is x squared plus 1. So we need to consider a quadratic expression here, because this is a quadratic function. So we have to consider yp to be ax squared plus bx plus c. So if yp is this, what is yp second prime? I mean yp the first, yp first prime. Yp first prime is going to be 2 times ax plus b, as you see. And if you apply extra derivative, it will be yp second prime, and it is 2a. So now if yp prime and yp second prime are substituted directly into our equation here, see, into this, the following can come. Look, in place of y second prime, you just simply use 2a as it is written. So here it says minus 3, so have minus 3 here, and in place of y prime, so this is 2ax plus b. Students, there is y prime here, please include that one, plus 2 times, what is y? Y is ax squared plus bx plus c. So all this must be simplified to x squared plus 1. So let's now operate the left expressions, or simplify the left expressions. So as you are doing that, the following can come. 2a is equal to 1, because the coefficient of x squared here must match with the coefficient of x squared here, but the coefficient of x squared here is 2a, and the coefficient of x squared here is 1, so 2a must match with 1. So from this, a can be 1 over 2. Let's now come to see the coefficient of x. As you see, the coefficient of x is minus 6a, because 3 minus 3 times 2a makes minus 6a. Minus 6a plus, come here, 2 times b is 2b. So minus 6a plus 2b is going to be the coefficient of x, and that has to be matched with the coefficient of x to the right side. But we don't have here coefficient of x, and this means that the coefficient of x is 0. So this minus 6a plus 2b equals 0, and we knew what a is. It's already obtained, it's 1 over 2. So if this is 1 over 2, it's going to be positive 3, I mean negative 3, and when you shift that one to the right, so it will be positive 3. So dividing both sides by 2, you will have b to be 3 over 2. Now we need to consider the constants. Here the constant is 2a. Here we can also have another constant, minus 3b. So we can take 2a plus minus 3b, and here we have 2 times c, another constant 2c. So 2a minus 3b plus 2c must add to make 1, because the constant here is 1. So here it is. But we knew what a and b are, and from this we can know what c is. Since a is 1 over 2, 2 times 1 over 2 is 1, as you see, and b is 3 over 2, so minus 3 times 3 over 2 is minus 9 over 2. We are having 2 times of c equals 1, and from this c can be 9 over 4, as you see. Thus, students, yp now is determined because the values of a, b, and c are known. Hence, yp is 1 over 2x squared plus 3 over 2x plus 9 over 4. I simply substituted the obtained values a, b, c here directly in the quadratic equation. Therefore, yh is known. Now yp is also known. So the general solution is going to be the sum of the two. So in order to determine now the general solution, yh is here. So you just take this one, and yp is here. You just again take this, try to take the sum of the two. That makes your calculation over. As you see, y is the sum of the particular as well as the homogeneous one. So this makes your calculation over. Now when you go to the next one, which actually is again this, I'm going to return back, I think, because I just have passed one slide. So when we go to that, let's come to question number, sorry students, when we come to the other question, let's just come to, yeah, this one. This is undetermined coefficient. Here it is. Okay, this one here we have. So let's now do this together. It says, using the undetermined coefficient method again, you are asked to solve this particular differential equation. As you see, you are asked to solve this. So how are we going to find the solution for this one? So let's see how we can do. The homogeneous differential equation for this is going to be this: y second prime plus y prime minus 2y equals 0. So characteristic equation for this is going to be m squared plus m minus 2 is equal to 0. So think of two numbers again where their sum can be positive 1 and product minus 2. These are m plus 2 and m minus 1. So as you are solving this, you will obtain m values to be 8 minus 2 and 1. So the solution for this homogeneous is going to be c1 e to the power of minus 2x plus c2 e to the power of x. And next we need to determine the particular solution. And to find the particular solution, we have to consider what has been written here. See, as the yp1. So your yp is going to be dependent on the function written here. So as you see, this one, it is 2 times e to the power of 2x. And what has been written as the coefficient of x is 2. Is 2 the root for this characteristic equation? No. So if it is not, we can now consider yp to be a times e to the power of 2x, where a is a constant 1. But if 2 is one of the roots, we could have taken here x times a e to the power of 2x as your yp expression. And again, if 2 is a double root for this characteristic equation, we could have taken x squared times a times e to the power of 2x. So you have to take this consideration. But now 2 is not the roots because the roots are minus 2 and 1. So we can take yp to be a times e to the power of 2x. So take the derivative of that. It will be 2 times a e to the power of 2x. The second derivative makes for a e to the power of 2x. So let's directly substitute all this value there in the differential equation, so we can have these expressions. Basically, this is obtained directly substituting the obtained solutions here, obtained expressions here in our differential equation here directly. So let's simplify here. Look, they all are identical. 4 plus 2 makes 6, 6 minus 2, 4. So 4a is the power of 2x must match with 2 e is the power of 2x. So from this, e the power of 2x can be cancelled by the power of 2x. Then 4a equals to 2 can come, and from this a equals 1 over 2 can follow. So the particular solution is going to be yp a is the power of 2x, but a is already obtained, it's 1 over 2 e the power of 2x. So we knew the homogeneous solution, here it is, and the particular solution is now obtained. So the sum of the two makes what? The final solution. So the final solution is going to be y is equal to c1 e to the power of minus 2x plus c2 e to the power of x, the homogeneous solution, plus the particular solution. This is how it can be done. I hope it's very simple. You can understand this in a simple way.